Let's begin by asking a fundamental question. What is a fluid? Or perhaps, what distinguishes a fluid from a solid? Intuitively, we think of a solid as hard and resistant to deformation, while a fluid is soft and easily deforms. For instance, we can move effortlessly through air or pour water into a container, but we can't take a steel object and bend it with our hands unless we are some kind of bodybuilder, right? These observations, though useful, are not precise enough for scientific or engineering purposes. Now, to refine our understanding, we have to take matter and we have to examine the molecular structure of materials. Solids, such as steel or concrete, consist of densely packed molecules held together by strong intermolecular forces. These forces are called cohesive forces, and we will talk more about cohesive forces in section 2 when we talk about surface tension and capillary action. These forces enable solids to maintain a fixed shape and resist deformation. Intermolecular forces are strong. In contrast, liquids, like water or oil, have molecules that are spaced further apart from each other, with weaker intermolecular bonds. This allows liquids to deform more easily, though they are not easily compressed, and they take shape of their containers or flow through tubes. Gases, such as air or oxygen, have even greater molecular spacing, and they have negligible cohesive forces. So their molecules are all around and they move freely, enabling gases to deform readily, be compressed, and expand to fill any container completely. Now, both fluids and gases share the property of easy deformation and are collectively classified as fluids. Now, this right here is shearing stress, which is the tangential force per unit area that force is acting on. Arises whenever we have forces acting parallel to the surface as shown in this picture. In solids like steel or other metals, applying a shearing stress typically results in a small, finite deformation that remains static. The material resists further movement and does not flow. Now, while the distinction between solids and fluids can often be described in terms of molecular structure, a more rigorous differentiation lies in how they respond to external forces. So, like this shearing stress, for example. Now, the definition of a fluid is that a fluid is a liquid, gas, or other material that may continuously move and deform, flow, under an applied shear stress or external force. So continuously move, continuously deform, in other words, flow, and mind you, other material, which means it can also be a mix between liquids and solids and slushes, slurries, whatever. So a fluid can be anything that continuously moves and deforms under an applied shear stress or an external force. So not only easy deformation, but the deformation that is continuous. Jello is easily deformable, for example, but it goes back to its original shape when the force is not applied. This means that it is just matter that is very elastic. So what ultimately separates fluids from solids is their continuous deformation when a force is applied, or in layman language, flow. Fluids flow. Some materials, however, blur the line between solids and fluids. A substance like toothpaste, tar, or slurries behave as solids under low shearing stresses and low forces, but begin to flow once the stress exceeds a certain threshold. These materials fall into the realm of rheology, and we will talk more about this phenomena in this section when we talk about rheology and the classification of Newtonian and non-Newtonian fluids. Thank you for listening and for staying focused, and see you in the next lesson.